Okay, I believe you can hear me now, right? Okay, great. So I can see Shafiq already say yes. I believe the rest also can hear me. And I also on my video together with my mic. Sorry for the delay just now. I tried to use my tab, but my tab using Skype, but unfortunately, I think Skype cannot handle a big group. I meant to understand that Skype can, there's no limit for participant in Skype, but I believe my tab or my internet, my Unify cannot handle the big number of participants in the group. Yeah. Um, Maybe it's appropriate to welcome all you back. I believe most of you, this is your first day having a lecture online. This is in fact also my first lecture online for undergraduate, although in the past 6 weeks, I've been conducting online class using Skype with the Master by Thought course, the postgraduate Master by Thought course for mechanical engineering departments. That's why I expect that I can continue with Skype, but what I have found out just now, it's lagging. When I open Skype, I cannot open other window applications. So I cannot upload the QR code. I cannot open my ellipse, etc. Yeah. So I take the initiative to change the tab into a proper laptop, and seems to be working well now. This is a temporary WebEx connection that we will use for today. Maybe next time on Friday, when we have our next class on Friday, I will use my own WebEx. Yeah. Okay. If you look at the course plan, I believe I have covered with you the basic concept of instrumentations and control, and probably Dr. Fikri did repeat that again with you, and then as well as the one on flow measurements. Yeah, I covered flow measurements, and I believe Dr. Fikri also covered flow measurements with you after he took over in week 3 or in week 4, I think, before the MCO. Yeah. And I believe that Dr. Fikri also have covered with you pressure measurements, as well as temperature measurements, level measurements, analytical measurements, humidity measurements. And that means I only left with 3 weeks to cover. But Dr. Fikri mentioned to me that I will take over from him from this week until the end of the semester. Yeah, as you already know, our semester already being the timetable already being changed. Yeah, our week 8 is actually starting from this week. So this is week 8. So that means I will have 7 weeks with you to cover on control. Yeah. So as you can see here in the course plan for control, we have 3 weeks. 3 weeks to cover process control. So I have more than double the time that I'm supposed to have to cover control view. Yeah. So for the start, we look into basic elements of a controller, and then relationships between gain and feedback. And then from there, we move to delay and lags, as well as mathematical functions. And then we look into some applications of flow, pressure, and level control. Yeah. So that's what we're going to do for this the second half of semester after the MCO. Yeah. Or after the CMCO, if you like. Yeah. Which critically will end today. Yeah. So that is on the course plan. Yeah. So if I move to what I should cover with you on control, will be By the way, also, I have seen that Dr. Fikri already given to you up to 5 assignments, yeah, up to the assignment 5 on humidity measurements. So from my discussions with Dr. Fikri, he mentioned to me that I don't have to give you any more assignment, right? Yeah. So I don't have to give you any more assignment, but nevertheless, he asked me to prepare one question as your final examinations. So that one question will carry 25%. Yeah. So that 25% considered as a big assignment. Yeah. And with that, I will come up with the assignments which we will discuss this Friday. Yeah, on a Friday morning, I will discuss with you one big assignment, and this assignment supposedly of or complex in nature. Yeah, so you need to write a report, something that more than 10 pages, or 10 pages, but probably not more than 20 pages. Yeah, as your to replace your final exam. Yeah, so that's the only assessment that I will have, that I will give to you for this course. Yeah, only one big assignment which will replace your final exam. Yeah, so you don't have to worry that I give you more tests or assignments. But nevertheless, Dr. Fikri will inform you when you will have your test one, which is supposed to be conducted this week. But because the MCO and CMCO, the test one already been delayed, and Dr. Fikri will inform you when that test will be conducted. Yeah. Any questions? No. Everyone can hear me clearly? I think WebEx can handle this big class, right? I saw that there are about 100 of you. Okay, great. So for today, I think since this is the first time we have an online class, I make it a bit short. Yeah, basically I just introduce to you what will I cover for this half semester, for this 7 weeks from week 8 until week 14. Yeah, so I just briefly mentioned to you just now that your test one, Dr. Fikri will post that question for test one for you. Yeah. Now I just look at this brief PowerPoint presentations on control.
Oh, okay. So
yeah, you can see this question, this PowerPoint, right? Okay. So instrumentation and control on control part. Yeah. This is the topic that we cover. We look into the basic elements of a controller. Yeah. When you learn about the level measurements, flow measurements, temperature measurements, humidity measurements, etc., I believe you already know what type of instruments you need to use to do the measurements, right? So now basically we're talking about a control system, or in other words, a controller. So we need to look into what is actually a controller. So what are the basic elements of a controller in this case? Yeah, and then normally a controller having a basic elements in such a way that it can do the measurements. Yeah, so when you do the measurements, you have a signal. Yeah, and that signal will be sent to a computer. Yeah. So inside the computer will be a controller. Yeah, and then based on the measurements that are measured by your instruments and the signal that's sent to a controller. Yeah. In this case, the computer, where inside the computer there will be a program. Yeah. such as a PLC or programmable logic controller in this computer. Yeah, the computer will try to tell your systems, yeah, whether the measurements already reach the set point that you set for that particular process, for example, yeah, and then with that it will give you something like feedback to the systems, whether to reduce or increase. Maybe, for example, if you're talking about measurement temperature, if the temperature is too high, for example, if the set point is low, is higher than the current measurements, then the feedback will try to tell the systems or the process to increase the temperature, for example. Yeah? So this is what it means with the gain and feedback. Yeah. The next will be delay or lags. Yeah. For example, just now when we try to set up the systems, for example, yeah, due to the probably not a very good internet systems, maybe, yeah, because they are not yet come to 5G, but instead probably not even 4G, maybe. Yeah. So some of us probably not even come to 4G. Yeah. Even if it's 4G, for example, but you cannot handle the big data. Yeah. So there'll be a delay or lags, for example. So in this case, we have no choice, but we have to come up with better systems. Yeah. So in our case this afternoon, I have changed my computer, for example, from a tab to a proper computer, and with that we minimize the what's called the delay or lags in the systems. Yeah. So that's what we mean with delay or lags. So with that, knowing the gain and the feedback, the delay and lags, yeah, based on your instrumentation that you use to do the measurements now, yeah, and together with the computer that act as the controller with the programs of computer, it will give you some kind of control actions. Yeah? So this is the things that we need to consider. Yeah, and ideally we don't want to do a manual control. Yeah, we prefer to have an automatic controller. Yeah, so this means we have automatic process. We have an automatic process controller. Yeah, so in this course, in this next 7 weeks, we will have we try to have a case study and as well as some assignment on how to have automatic process controller in our control systems. Yeah. So that is the topic that we're going to discuss. Yeah, I just quickly covered with you what are the basic elements in a control systems. Yeah, basically there are 4 essential features of a controller. One, we must have a measurement as an input. Yeah, so we have learned about measurements of flow, for example, where we want to measure the flow rate, for example. Yeah, from the flow rate you can have you can also have other measurements like pressure measurements, yeah, velocity measurements, etc. Yeah, and also other parameter like temperature or humidity, etc. Yeah, so that measurement become as the input to your control systems. Yeah, and here we need to offer the means for generating or accepting a set point. Yeah, so for example, in setting a temperature, for example, you set temperature at 100 degrees Celsius, for example, yeah, and your instruments give you measurements of only 80 degrees Celsius being measured at that time. Yeah, so your controller will try to engage probably the heater to give to heat the water further so they can reach the temperature to 100 degrees Celsius. Yeah, and once the set point being reached, for example, at 100 degrees Celsius, yeah, and you want to maintain the operating temperature at that 100 degrees Celsius. So in this case, you need to make sure that the heater needs to supply enough energy, yeah, to maintain the water temperature at that particular set point of 100 degrees Celsius. Yeah. So your control systems, in this case, try to do that. Yeah. And you also have must have the ability of comparing the set point with the measurements and registering the resultant error. Yeah. So how to compare the current measurement of temperature? Yeah, talking about temperature measurements. Compare with that the temperature that you set for that particular process. Yeah. So the difference actually gives you the error. Yeah. And then here also we need to consider also why the temperature of the water that we try to boil to 100 degrees Celsius cannot reach to 100 degrees Celsius, for example. Yeah. So we need to look at the reasons to this particular difference. Yeah. Could be due to some errors, for example, or disturbance, for example. In case of leakage, for example, the water leakage from the systems, maybe. Yeah. So you cannot um, stabilize the temperature, or maybe also due to the noise in the measurements, maybe that could also can lead to error. Yeah. And the fourth feature actually, it must be capable of producing an output of sufficient magnitude and directions to correct any deviations from the desired value. Yeah. So these four actually the essential features of any control systems, or the things that a control system must have as a basic element. Yeah. So we quickly go look at what it means with gain and feedback. Yeah. So gain actually consider as the ratio of output over the input. Yeah. With the symbol G, and output we give a symbol V, and input theta. Yeah. And feedback control systems are closed loops in which the measurement is altered directly by control output. Yeah. So for a positive outback, for example, yeah, we have theta plus the feedback from the output. Yeah. But if you have negative feedback, then we have the output theta as minus the negative output in this case. Yeah. So the open loop for open loop control systems, control action is normally independent of the output. Yeah, there's no feedback for the open loop control systems. Yeah. So we also have components in or instruments in series as well as in parallel. Yeah. In case of components or instruments in series, yeah, the output the gain in output is actually the multiplications of all the each of the components gain in that particular series. Yeah. But if you have components in parallel, yeah, then the gain will be instead of multiplication become the sum of the gains in series. Yeah. So you have three instruments, for example, with each gain 1, gain 2, and gain 3. Then if the components in parallel, then the total gain is actually the sum of them, G1 plus G2 plus G3. Yeah? Whereas if they are in series, then it will be the multiplications of them, G1, G2, and G3. Yeah. So that's the idea of gain and feedback in a control systems. What it means is delays or lags in this case. Delay or lags actually defined as the time required for the sensor to produce a signal that represent the measured parameter. Yeah. So you can imagine when I talk to you, if the systems being perfect, the internet are perfect, then you can hear me almost instantly. Yeah. But let's say if there are some delay or lags in the systems, you probably hear me a couple of seconds after I say the words. Yeah. So in this case, the delay or lags actually defined as the time given by the distance over the velocity, yeah, or L over V. And an example of transfer lag, for example, from what you have learned in the first part of the semester on instrumentation. For example, when we try to measure the pressure, for example, yeah, there will be sometimes for the pressure to settle down, yeah, in a differential pressure instruments, for example, and same goes to Borden type instruments as well, yeah. Or for float operated level measurement also it takes sometimes for the ball to settle, for example, yeah, on the surface, yeah, and until you can get a stable measurement of the level, yeah, based on the float of the float on the surface of the water, yeah. And the same goes to other analytical measurements, for example, the pH, for example, yeah. It will take some time for you to measure it. Uh, the concentrations, a tank, etc. Yeah. So that is the delay and the lags. Yeah, and also on the lag, and also some of the elements. Yeah, in control. So now we move to a summary of the control actions. Yeah, what are the basic controller actions? Yeah, the one that we on and off, that is one-off systems, or we have the multi-step and as well as the plotting systems. Yeah. So for the plot multi-step, we have a few steps to do the control actions. Yeah. And then we also have the three-term process controller. Yeah. So this is for with regards to automations. Yeah. We're talking about either proportionals, integral, or derivative. Yeah. So proportionals normally like y equal to mx. So this is proportionals. Integral talking about integrated, and derivative with respect to time. Yeah. So for this automatic control, which normally based on a proportional, integral, and derivative, yeah. Normally for proportionals, the output given by the proportionals gain k times the ER, yeah. And for integral, we have the gain k, the integral gain k2 times the integral of ER over time dt, yeah. Whereas for derivative, we're talking about the derivative gain k3, yeah. Times the different differentiations of ER over dt, yeah. And sometimes in automatic control systems, it probably is combinations of either proportional, integral, and derivative. Yeah, they are not working independently, but they are probably in the combinations of two or even three of these. Yeah, they are not just work in one. Yeah, so this is basically the summary of the control systems. Yeah, what we're going to do next, actually, this Friday, yeah, we look into one or two case study, and from that case study, we will set your assignment, yeah. And this assignment actually will require sometimes for you to do it, yeah. And once we finalize it, probably by week 12, yeah, that's mean about 1 month from now, you will start to write your report so you gathered enough information, yeah. And then this report for this particular assignment will be part of your final exam, yeah. So it'll be a big assignment. So to justify that it is complex enough for you, yeah, to be considered as a final exam, to replace final exam questions in this case. Yeah, it's big because the total mark for this particular assignment will be 25%. Yeah, so for example, maybe we're talking about a case study of how to control the transfer of oil from, let's say, from an oil platform a few kilometers at the sea, for example. Yeah, they need to transfer using a pipeline from offshore to onshore. Yeah, so when you want to do this, for example, yeah, you need to know the measurement of temperature, perhaps the measurement of flow rate, as well as pressure. Yeah, on top of that, probably you need to also need to do some measurements on viscosity of the oil, maybe, so that you can control the velocity of the transfer from offshore to onshore. Yeah, and then in the case study on a pipeline system, probably also we include something additional from what we have outlined in the cost plan. For example, we need to consider what happens if there are blockage along the pipeline, for example. Yeah, because when we extract oil, for example, from the ground, yeah, you can imagine that there are a lot of particulates like sands, etc. Yeah, so they are not just liquid that being transferred from by the pipeline from offshore to onshore, but also include other solid particles. Yeah, and we want this the pipeline to be able to filter out all the solid. Yeah, before it can reach onshore, for example. Yeah, to the installations site onshore. Yeah, because if they are solid in the pipeline, it might damage the pipeline, for example. Yeah, so in this case, I will include in our lecture a brief topic on filtration systems, for example. Yeah, so that will help you to make it a bit more complicated. When you want to write your assignment later on. Yeah, that will include filtration systems and what kind of instrumentation systems that being used in that kind of systems when there are blockage, for example, which normally will reduce the flow rate or maybe increase the pressure and temperature as the result of a blockage, for example. Yeah, so that's the things you need to consider. Any questions want to ask? This is a brief introduction to on control systems. Yeah, I will give more details on the assignments. Yeah, and more details on the control systems in our next lecture that is on Friday morning. Yeah. Any questions? Okay, if we did not have much questions, okay, why don't you just ask with regards to group assignment. There will be no more group assignment because we only have one assignments which will replace your final exam for this control part. Yeah. So that's what I understand from Dr. Victory. So I only need to set one assignment which will replace the final exam. Yeah. So for as far as our final exam is concerned, yeah, you're not supposed to be a group assignment. It's supposed to be individual. Hmm? Okay, for the pull-out TRISO assignment, yeah, you need to submit it online, yeah, and upload your report in ELIP, but there will not be any. I think we do away with presentations, but you need to submit your report for the pull-out TRISO assignment. Yeah. Is that okay? So you can submit it in the link in Elip for the plot result report. Okay. So the assignment that I mentioned just now is the individual assignment to replace your final exam, yeah, based on control systems, and we discuss it further on Friday. Yeah. Correct. There'll be two in assignment. One, the individual assignment, which will replace your final exam. But I will only give to you that questions by week 12, because they are giving a window of something like 2 weeks to do the assignment. Yeah, because it's considered as a final. Yeah. But your group assignment, I've already given to you in week 2 or week 3 before the MCO, right? So I hope that you will not have much problems with it, because it's a group assignment that you need. This means that you need to interact with other members in the group. But I make it a bit easier for you, that you don't have to come up with the presentations for that. You don't need to present it. You just need to come up with a report, group report for that particular assignment. Is that okay? Yeah. So that's the case. Then you don't have to meet your friend physically in order to come up with the presentations video for that, because they're not allowed to conduct a class until year end, right? So it's not easy to come up with a video where 4 or 5 of you in the group need to come up with a group effort for that. Yeah? But I think for report, you can just simply you can meet, not need to meet, but you can email each other or message each other your part of the reports. Yeah. But let's say if you already done the presentations video for that, you can, yeah, you can upload it as well in the link, in the ELIP link, yeah, together with your reports. Yeah? Any other questions on that, on the group assignment, as well as the coming individual assignments that will replace the final exam? Okay, if no questions, probably we can stop a bit early today by 8:30. You can leave if you want, but if you still have questions, you can stay on, and I will take your questions and answer your questions until 3:30.
Thank you, sir.
Okay, welcome. The due date for the plot result will be before week 12. Is that okay? Or by the end of week 12 in this case. Anyone else want to ask questions? Otherwise, we can close we can conclude the meeting, and then we can meet again on Friday, 10 o'clock. Yeah. So on Friday, we um, try to get it ready much earlier than 10 o'clock. Yeah. Okay. So this is a brief meeting for first meeting for this is second half of the semester, and we continue again on Friday morning. Yeah. Okay.